So what is constraint relation? First try to understand. So what is meaning of constraint relation? Then we will try to understand how to find the constraint relation. So first we will see what is meaning of constraint relation. So constraint relation means the relation between different parts of connected body system. Relation between motion of different parts of a connected body system. So this is what this is, relation between different parts of a connected body system, different parts of a connected body system. So what is it meaning? What is meaning of this? See, if we have some body connected to each other, for example, suppose we have a string and one mass is hanging here and another mass is hanging like this. So the motion of these two objects, the M1 and M2, if we say the motion of M1 and M2 are not independent to each other, they are related. If M2 will go down by X, the M1 has to go up by same amount X. So this is called constraint relation. So this is the called constrained motion, means the motion are not independent. Constrained motion means they are related to each other, the motion of two parts of system. So this is connected body system and these are the two parts. M1 and M2 are two parts. The motion of these two parts are related to each other. So this is called constrained motion. So what is constrained motion? So constrained motion is the motion which has to follow some condition, the motion of different parts which are related. Different parts of a system having related motion, different part of a system having related motion. Having related motion. So this is the constraint relation. This is a constrained motion, means the motion is not independent. Motion is not independent. Motion is not independent. Okay, so this is the just definition. So now we will see how can we find the constraint relation. How can we find the constraint relation of different objects? So we will take a simple example. So suppose we consider this example one. We take, suppose we have in pulley, we have a pulley and we have an object like this and we have another object like this. Okay, so this is M1 and this is M2. This is M2. We have to find what will be the relation between the motion of these two objects. So for that, what we are going to do is we will write the distance of this object from the pulley. So what we have to do, what is the basic method? The basic method is we will write the position of the object with respect to some fixed point. So fixed point is pulley here. So the distance of this object is, suppose we write x2, and distance of this object, suppose we write x1. And what is the constraint equation? What is equation corresponding to this constraint motion? The x1, the length, the total length of a string is fixed. So we can write x1 plus x2. We can write x1 plus x2 equal to L. This is the constraint equation. This is constraint equation. Okay, so x1, the length, this side length, the length for the string on side M1 and length of the string on side M2. If added, that must be equal to the total length L, and this is constant. L is constant. Okay, now if you want to relate it with velocity, if you differentiate it, then it will become dx1 by dt. This will become dx2 by dt. And since the total length is fixed, so dl by dt will become 0. So we can write v1, dx1 by dt is v1, dx2 by dt is v2, that equal to 0. Why 0? Because this is constant. The L is constant. That's why the differentiation of L is 0. Okay, so what next we are going to do? If you differentiate it again, you will have a1 plus a2 equal to 0. Okay, so what does it mean? It means that acceleration of these two objects, if acceleration of one is, suppose we can see that if acceleration of one is suppose a upward, then it will be downward with same amount. You can see the magnitude is same and direction is opposite. So if acceleration of m1 is upward a, then acceleration of m2 will be downward a. So in this way you can relate. So this is the constraint relation. So this thing also we have done in the this relation we have also used, we have already used, and these relations are simpler to understand. But the method which we have just discussed here, this method can be used for more complex problems. So this problem is very easy and this could be done even without applying the method. And you can have this result by using this method. And this method we will be using for more complex systems.